Hello, Hart Hagen here. So the Union of Concerned Scientists has put out an article on farming and climate change. So how is climate change going to impact farming given the status of farming such as it is, especially in the United States? So let's see what they have to say. It says, climate change and agriculture, a perfect storm in farm country. Here's a really nice picture. If you can see that, I think you can. Yeah, grain elevators, a big windstorm in the back, and Gabe Brown and others have been talking about the new Dust Bowl. You would think that the Dust Bowl was a thing of the past in the 30s. There was a time in the 30s when the Dust Bowl was this whole big thing. It coincided with the Great Depression. It was like adding insult to injury. You had these lands that were just kind of exhausted. They had been tilled, they'd been plowed, the soil had been mistreated. All of a sudden, they were just, ground pulverized dust and dirt. And, FDR, Franklin Delano Roosevelt, famously said, a nation that destroys its soils destroys itself. But yet, in the meantime, they never quite figured out how to treat our soils well. You have these kind of anti-erosion programs, but the best anti-erosion program is the 5 Principles of Soil Health, as set forth in Dirt to Soil by Gabe Brown. Gabe will tell you, I didn't invent these, nature invented them. I might have been one of the first to articulate it. Ray Archuleta is another one of those who articulated the principles of soil health, which is, avoid tillage, avoid chemical fertilizers, avoid herbicides, avoid bare soil, in that you're going to cover the ground at all times. You want to cover the ground with organic matter such as mulch. Or if you cover the ground either with organic matter such as mulch or crop clippings, or living plants. You can always cover the ground with living plants, but bare soil is a no-no. So tillage and plowing are a no-no. Herbicides, pesticides are a no-no, and chemical fertilizers are just degrade the soil. And what you want to do is cover the ground. What you also want to do is have living roots in the ground at all times, because living roots, let me click out of this. You want to have living roots in the ground at all times, because living roots inject sugars into the soil. The sugars start this whole soil food web. And you also want to have a diversity of living roots. So those are kind of a quick rundown of the principles of soil health. One of the things I like to say about principles of soil health is you have to do the opposite of nearly everything you've ever heard and seen. Because most of us have grown up with what could be called conventional agriculture, even conventional gardening. You have to use fertilizers because the plants are seen as taking from the soil. But if you see the plants as giving to the soil, then and the living roots are the best fertilizers, if you will. So anyway, let's go on to see what the Union of Concerned Scientists has to say here. They're saying, as our climate continues to heat up and the impacts of that warming grow more frequent and severe, farmers and farm communities around the world will be increasingly challenged. And U.S. farmers won't be spared the damage that climate change is already beginning to inflict. So what's going on in this narrative that I continually talk about is that the narrative, or the cause and effect that we're invited to, this cause and effect, this understanding of climate change surrounds us. And it's the idea that First there was a perfect planet, and then we started using a lot of fossil fuels. Those fossil fuels put a lot of extra carbon dioxide in the air. The carbon dioxide is a greenhouse gas. It causes warming, and then all other problems flow from that. That's not my understanding of the cause and effect relationship we're going with here, but that is what pervades us, that fossil fuels lead to greenhouse gases lead to all other bad things, including flooding and drought, wildfires, heat waves, diminished agricultural production, diminished access to water, so that, if somewhere in the world, well, lots of people don't have access to clean drinking water, we're going to blame that on climate change. Anyway, let's continue to read here. In fact, the industrial model that dominates our nation's agriculture, a model that neglects soils, reduces diversity, and relies too heavily on fertilizers, makes the farm susceptible to climate impacts in several ways. Now, I think they're getting at something here that is very important. They say true things, and they just barely miss the main part of the story. So what they're saying here is that the industrial model that dominates our nation's agriculture, a model that the industrial model is a model that neglects soils and reduces diversity. Now, by diversity here, they could be talking about biological diversity. More likely, they're talking about the diversity of different farm products. You want to have multiple streams of income, if possible. You want your farm, if possible, to not rely on only one crop, but mainly most farms are relying on one or two crops, not much diversity, not much rotation from year to year. Certainly farms in the last 70 years or so, since the early 1950s, have gone to, you have farms that are raising crops, and then other farms that are raising livestock, and the two, never the twain shall meet. So Wendell Berry has a great saying about this. He says that, I'm paraphrasing, but back in the old days, it used to be a farm would have both plants and animals, both crops and livestock. The livestock would provide manure to fertilize the crops, and the crops would provide some excess feed to feed the livestock. And but now what we've done, we have some farms that raise crops, other farms that raise livestock. The farms that raise livestock generate excess manure that is a pollutant. It's toxic. There's so much manure in moderation and in the right place at the right time is a fertilizer, is a benefit because you can use that to fertilize your crops. But we have too much fertilizer, too much manure, too much urine, too much poop, all in the same place, and it becomes a toxic pollutant. And then over here, you have crops those crops don't have animal manure to fertilize them, but what you do is you bring in chemical fertilizers from way far away. And those chemical fertilizers are needed. They're expensive, but you use them to fertilize your crops, and that also becomes a pollutant, because most of the fertilizer that you put down does not actually fertilize the plant. It washes off into the streams and waterways. One reason it washes off is because your soils are highly erodible. The soils are highly erodible because you have not practiced the principles of soil health. You have, you've used tillage and chemical fertilizers and herbicides and that is bad for the soil. The tillage alone, you go through and you till, the soil had structure, but then you came along and you tilled, you destroy the soil structure. So when you destroy the soil structure, it's just a kind of a mass of minerals, and which is easily eroded. The rain comes along, washes away the soil. With the soil, it washes away the chemical fertilizers. The chemical fertilizers end up being, they end up in the waterways where they're not wanted or needed. And, when there's too much nitrogen in the waterways, then that water becomes easily too toxic for human consumption. Plus, it flows all the way out from the waterways, from the rivers out into the ocean, creates dead zones in the ocean, because you have zones in the ocean that don't have enough oxygen for the fish. So anyway, it's a big mess. And what got me off on all that was that what got me off on all that was this thing about diversity. Our nation's agriculture, the industrial model that dominates our nation agriculture, is a model that neglects soils, reduces diversity, and relies too heavily on fertilizers and pesticides. Absolutely true. It makes the U.S. farms susceptible to climate impacts in several ways. Reading on. Let me see. I need to show you what I'm reading here. So I'm going to click on that. So the combination of advancing climate change and an already vulnerable industrial system is a perfect storm that threatens farmers' livelihoods and our food supply. The good news, now, what they're emphasizing here, the word vulnerable is a key word. Vulnerable industrial farming system is vulnerable to climate change. What they don't say is that this system in large measure creates climate change, because it eliminates ecosystems. It eliminates the functions of ecosystems that would otherwise prevent at least the symptoms, and I think the causes of climate change. So when you think of climate change, what are they talking about? They're talking about flooding and droughts and wildfires. And all of these things are like, why is climate change a problem? Not just because of the additional warming, but because of the flooding that it brings. Supposedly, climate change brings flooding in the prevailing model, in the prevailing narrative. Supposedly, climate change brings droughts in the prevailing narrative. So what they're saying here is that our industrial farming system is such that it brings flooding. Well, our industrial farm system is vulnerable to these things. They don't say that the industrial farming system, such as it is, causes climate change to a great deal. Now, if you're a farmer, I don't want you to be offended by this. If you're a farmer, you're doing your best to make a living. You're doing what you feel like you need to do. It's not easy to change. It's not your job alone to bear the burden of change. So keep doing what you feel like you need to do. But we're talking about this from a public perspective here. What public policies could change that would make it easier for farming to be conducted in a way that is good for the climate and good for wildlife, good for water quality? And if we can do that, then at the same time, it will be a type of farming that increases the value of your land year by year by year. Because if you're practicing the principles of soil health, then year by year by year, your farm becomes ever more valuable, because your soil, you're increasing the quality of your soil over the course of time. You're increasing the ability of your soil to capture rainfall, to fertilize plants, to make plants more resilient, et cetera, et cetera. So let's go back to what they're saying. The good news is that there are tools in the form of science-based farming practices that can buffer farmers from climate change and help make their operations more resilient and sustainable for the long term. but farmers face many obstacles to changing practices, so it's critical that policymakers shift federal agriculture investments to support and accelerate this transition. So they're saying that, look, public policy matters. Public policy can either facilitate, it can either keep business as usual entrenched, or it can lay the groundwork for positive change. Give me just a minute here to get to the next thing. It says how climate change will challenge farmers. Various authoritative reports, most notably the multi-agency 2018 Fourth National Climate Assessment, have reviewed what science is telling U.S. farmers to expect in coming decades, and it's not pretty. So, climate change trends. Changing precipitation patterns, rainfall patterns have already begun shifting across the country, and such changes are expected to intensify over the coming years. This is likely to mean more intense periods of heavy rain and longer dry periods, even within the same regions. Now, so yes, it's true that climate change, in the sense that they understand it, it's true that climate change causes more intense rainfall. You have longer dry spells and then more intense rainfall. This is true, but it's not true that this has to be necessarily a bad thing. And it would be better to have more consistent rainfall. But the next best thing, if you don't have consistent rainfall, is for your ground to capture the rain that does fall. That's called effective rainfall. If you're practicing the principles of soil health, then your soil has greater infiltration rates. Your soil, which means the rain that does fall soaks into the ground. If the rain does not soak into the ground, then you're getting this heavy rainfall that it's not as consistent or as regular or as gentle as it used to be. So you get this heavy rainfall and it causes flooding. But that flooding only occurs if the ground does not soak up the rain. If the ground soaks up the rain, then the flooding does not occur. Flooding is not a function of rainfall. Flooding is a function of runoff. Runoff is what happens by definition, runoff is what happens when the rain does not soak into the ground. If the rain soaks into the ground, you don't have flooding. This is so rarely understood. It's understood by a few innovators like Alan Savory, like Gabe Brown. Gabe Brown, author of the book Dirt to Soil, Alan Savory, author of the book and the Method and the Movement, that is holistic management. They understand that when the rain comes, your soil needs to be able to soak up the rain. And if it does, then you can thereby prevent both flooding and drought. And if your land is able to soak up the rainfall, then you're not going to have flooding. Plus, you're not going to have drought, because the worst part of drought is not the lack of precipitation. We think of drought as a period of time in which it does not rain. But the worst part of drought is when your land does not have enough water in it to water the plants in between rain events. You can have below average rainfall for year after year after year, but that's okay if your land is soaking up the rainfall. Your land will soak up the rainfall if you practice the principles of soil health, as explained by Gabe Brown in Dirt to Soil. See what else they have got saying here. So, changing temperature patterns. So they're going through the different things that scientists are telling farmers to expect. And what they have here is changing temperature patterns, rising average temperatures, so you have overall more heat, more extreme heat throughout the year, fewer sufficiently cool days during the winter, and more frequent cold season thaws likely to affect farmers in all regions. So, which is to say that the past is not equal to the future. Whatever we came to expect in the past is not necessarily going to be there for us anymore. And so, more extreme heat is obviously a problem because, extreme heat can adversely affect livestock. Extreme heat can adversely affect crops. Extreme heat can adversely affect soil temperatures, which, at a certain, when you get to high levels of temperatures, then the biology in the soil tends to not work for you anymore. Also, cold season thaws are important because in some, in some parts, if you're in a colder region, then you want it to freeze in the winter. That's what biologically, that's what the region is used to, and it can create issues if it in fact does not freeze as long or as much as it used to. Continuing to read here, climate change impacts. Now we're getting to it. I've already said this several times, even in this short thing, but let's just read what it says. Floods. We've already seen an increase in flooding in many agricultural regions of the country, including the Midwest, the Southern Plains, and California. Okay, so, but why is it flooding? Why is it flooding? They want you to think that flooding is because we're getting more rain. But flooding is not because we're getting more rain. Flooding is because the ground is not soaking up the rain that does come, the ground and the vegetation. So how can we make it so that the ground soaks up more rain? Well, one is to practice the principles of soil health. When you practice the principles of soil health, then more of the rain soaks into the ground instead of running off. Another is to have as much vegetation as you can. So if we're constantly deforesting, then that forest used to be a sponge which would capture the rainfall. And if you remove the forest, then it's not going to capture the rainfall. In a farming situation, hopefully you don't have crops fence row to fence row. I mean, that's what farmers were taught to do back by Earl Butz back in the 70s. Wendell Berry critiqued Earl Butz as part of his book, The Unsettling of America. But Earl Butz came in and said, you have to plant fence row to fence row, and then you plant fence row to fence row, but then you can't sell your crop for what you could. Farm goes out of business. Farmland gets bought up. You have fewer farms and bigger farms, but what it should be is that there should be some amount of land on the farm set aside just for trees. Now, this assumes that you're in an environment that has trees. Typically, this would be more the eastern United States, but also in the Plain States and the western United States. Insofar as your land naturally accommodates trees, you want to have some land set aside for those trees. Like, especially if it's in a semi-hilly area, you want the land on the top of the hill to continue to have trees. You don't want to go to the top of a hill and cut down the trees, because when you do, you have just removed the sponge. You want the forest on top of the hill to be a sponge, captures the rainfall, so that then that rain can gently be released into the streams and the waterways. That groundwater can, that groundwater can feed into the water table. The water table is, higher rather than lower. And that's what you want. So I was going through the different ways you can make sure we capture the rain that does fall. one is good soil, practice the principles of soil health. Another is vegetation, whether it's trees or plants or shrubs or a grassland. If you have more vegetation, then your ground is going to be more of a sponge that captures rainfall. If you practice the principles of soil health, you're also going to have more fungi and more animals in the soil. You want animals in the soil. You want fungi in the soil because the fungi is a whole big kingdom. You have plants, animals, and fungi. You want that kingdom of fungi to be there to provide diversity because the fungi has a positive relationship with the plants. Plants and the fungi work together. The fungi and the animals work together. The fungi and the bacteria work together. So you want fungi in your soil, and you want animals in your soil because animals burrow and animals do good things to the soil. Animals do good things to the plant matter, whether it's prairie dogs or beavers or even cattle and grazing animals, whether it's earthworms, whether it's dung beetles. You want animals in your environment. For example, if you're using insecticides, then you're killing off the beneficial insects as well as the insects that are considered pests or are considered problematic. So we want to we want to make sure that our land is able to capture the rainfall. And if we do that, we will be able to prevent floods. And then in an urban environment, we can prevent floods through infrastructure. We need our urban infrastructure to be able to capture the rain that falls. We need for our urban infrastructure to be able to we need it to be designed for hydration, not drainage. Our urban infrastructure, and this includes suburbs, includes wherever people exist, really is what I'm talking about. But wherever you are, we want to design more for hydration and less for drainage. Our stormwater, our storm drains are designed to receive the rainfall and then feed it as quick as possible into the streams and rivers. Well, so when we do that, we're treating water as a nuisance instead of treating water as a resource. We need to hold back as much of that rainwater as possible. Let it soak into the ground. Let it be available for wildlife. Let it be available for a healthy ecosystem that includes plants and animals and fungi and insects, etc. So that's about all the time I have, and appreciate you joining me. At some point, maybe we will look more at this article from the Union of Concerned Scientists about what climate change is bringing for agriculture, including what, in their understanding, climate change is bringing us flooding and drought and changes in crop and livestock viability. If you ask me, all of this stuff that they're talking about is much more a function of what we do to the land more than what we've done to the atmosphere. So let me wrap up with this kind of big picture summary of how things work in my view as it relates to climate change. So it matters a whole lot more what we do to the land than what we have done to the sky. What we've done to the sky is greenhouse gases. Whenever you hear about climate change, you almost always hear that it's all about carbon dioxide. It's carbon dioxide as a result of excessive burning of fossil fuels, and we need to put less carbon dioxide into the atmosphere. If you ask me, yes, carbon dioxide is a problem, but for reasons different from what we're told. If you ask me, fossil fuels, yes, are a problem, but for reasons different from what we are told. I don't think the burning of fossil fuels or excess carbon dioxide is the primary cause of climate change. And even if it were, climate change is not the primary problem we are dealing with. If I could show you a graph, and at some point I'll show you this graph of how the populations of wild vertebrates are plummeting, headed straight for the ground. If it were an aircraft, it's like, here's the curve going straight to the ground. It's getting more and more vertical as time goes on. Populations of wild vertebrates are going down fast. And it's primarily because of removal of habitat. It's also because of overhunting and overfishing and toxins in the environment. And all of those things matter, but it's primarily due to the removal of habitat, not least of all deforestation, and also the conversion of our agricultural system into something that, where our farms are less and less. Farms could be habitat for wildlife. There are less and less of that. That's another conversation. But another thing that alarms me more than mere warming of the atmosphere is the rapid decline of insect populations. Here, I know this is like opposite from what you would normally see as a graph, but the vertebrate insect populations are going, back a few hundred years ago, it was basically level, but then 1900s and 1800s, 1900s, 2000s, and by before the end of this century, that graph is just going straight to the ground. We can't live without insects. As Edward O. Wilson said, you can imagine a planet without humans, but you cannot imagine a planet without insects. If insects go, we go, plain and simple. Or even if that is not true, even if we could somehow find a way to survive without insects, it would be a world that is dirtier, more expensive, and less interesting for us to live in. And we don't want that to happen. So there are things that are in the environmental realm that are much more concerning than mere climate change, than the warming of the planet. And we need to look at those things. So more on that later. Thank you so much for joining me. Have a wonderful day.